Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, what we're going to do is we're going to build a metronome from scratch. So there's a question of, okay, if I have a blank project, how can we start developing a concept of time and tempo and beats per minute and playing and stopping states? How can we develop these from scratch? And I'm going to show you how to do this. So this is going to be part one of maybe a 2 or 3 part series. So before we get started, just got a couple announcements. First thing is, as always, we have the Patreon set up. So if you'd like to support the channel, it's much appreciated because it gives me a lot of motivation to do more videos like these. And we have a number of different rewards for different contributions. So we have t-shirts, we have hoodies, we also have time, like consulting time if you want to talk about code or if you want to talk about your career. You can also contribute, and I'm available to set up a meeting for that. So you can find that on the Patreon on patreon.com/theaudioprogrammer. Another thing is that I'm very excited that we're going to be offering some premium courses. So these are going to be courses that are going to be a little bit more in depth than the ones that I've been doing here on the YouTube channel. And we're also going to expand that out so that there are going to be other contributors that are going to be giving lessons and packages that are going to be a little bit more interactive. So you're going to be able to speak to tutors and get kind of real-time help on the lessons that you're doing. And they'll also be a little bit more in depth on various subjects such as C++, Juice, web audio, Max MSP, so on and so forth. So to find out more about that, you can sign up on the Audio Programmer. So the audioprogrammer.com/sign up. So let's go ahead and get started. So what I'm going to do is I'm going to create this from a blank audio application. And I'm just going to call this Metronome. And I'm going to create this here. So first thing that we're going to do is we're going to create a new class. So to do this, I need another CPP and header file. So if we just click on this plus button here, and what I'm going to do is I'm going to add a new CPP and header file. So make sure it's not add new component class, because it's not going to be a component. It's just going to be a metronome itself. So what we're going to do is we're just going to call this metronome with a capital M, because that's convention. And then we're just going to save it. I'm just going to take these, I'm going to move these into my main source folder. And as you can see, it's just a blank header file here and CPP file. And we're going to go ahead and open that up in our Xcode. So here we are in our Xcode. By the way, if you find this video helpful, be sure to like and subscribe if you're not already liking and subscribing to it. So here we are in our blank header file here. And what I'm going to do is I'm just going to go to the main component, and I'm just going to get this include here, this include hashtag that gives us all of our Juice methods and functionality here. And we're just going to put that here in our class. Okay, so we're going to go through this step by step. This first video is just going to get the very basics kind of set up, and then the second and third video will be going into a little bit more detail. So first thing we're going to do is we're just going to create a class. So we can just do that, called class metronome with a capital M. And then what I do is I just give it some brackets there. Make sure you put the semicolon at the end. Now we're going to have certain methods that we're going to want to access from other header files or other CPP files when we create a metronome object. So we're going to have public access. We're going to have certain things that are going to have private access. So things that we just want to keep to ourselves in this class that we don't need our main component to be able to see. Okay, so let's see. So let's go ahead and so we've done that. So now the first thing that we're going to do, pardon me, is we're going to jump over to our main component here, and we're going to just stop, and we're just going to have a little think about the concept of what we're going to do here. So the main thing that I'm thinking in my head. So there are a number of different ways that we can probably do this, but the way that I'm going to do it is that I want to have so we're going to have a concept of time. So when something starts, it's going to start counting, and then when it stops, it's going to stop. So I'm thinking that we need to have two different states, two different application states. So we need to have a play state where the song or the timer or the metronome is doing its thing, and then we're going to have it where it stops and then it stops counting. Okay, so to do this, like I said, there are a number of different ways that we could probably do this. I'm just going to change my formatting really quick to 4 spaces. There we go. And so the way I'm going to do this, I'm going to do this using a enum class. I'm just going to call this play state. And then we're going to have 2 application states. So one will be playing and one will be stopped. So the first one will be playing like this, and then we just put a comma, and then we have another application state called stopped. Okay. And now what we could do is we can go in here, erase this boilerplate code, and then what we want to do now is we want to start. We want to have a button, right? That'll probably when we click it, it's going to play, and when we click stop, when we click the stop button, it's going to stop. So we need 2 buttons. So we'll just call this text button, and then play. I'll call this play button, and we could put an argument in here of what we want the text to say. So we could say play, and then we can do another one here. We can call this stop button, and I'm just going to put that as stop. Now we can jump over to our CPP here, and I'm just going to get rid of all this business here. So actually, I'll keep that there. I'm going to change this size of this here to, let's just say 200, because we just want something that's small. And here we go. Just going to erase some of this other boilerplate here. And then I'm going to erase this here. And here we're going to go down here, and we're actually just going to, we're going to go back up here, and I'm going to start creating the buttons here. So let me just go ahead and open up the Juce API. So here we go. So text button, and here we are. So we're in the text button class. This is a class we've used in a number of tutorials before. So check some of the past tutorials if you're not familiar with it. Okay, so I'm going to fly a little bit through this because this is something that we've done so many times before. Okay, so first thing that we're going to do is we're going to say text button dot. So let's see here. So we got set toggle state. So we could do set toggle state. It's called play button. Play button. Set toggle state. So we don't want it to be playing when the application starts. So we want it to just be off when it starts. So I'm going to put this to false. Then notification type, we don't need to send any sort of notification. So it's going to be notification type, don't send notification. And then I'm going to add and make visible. And then I'm going to do play button. So this is making this a child component of the main component. I'm also going to do this this method here where it is, let's see, where are we? So if we go down to button public member functions, I can't seem to find it. Maybe it's in component. It's called set radio ID. Yeah, so set radio group ID. So this just means that what we could do is we could set it where when one button is on, the other button is off, and vice versa. Okay, so that's what we want to have happen here. So we got play button, set radio group ID. I'm just going to put this in group 1. Okay, and then I'm going to start doing this for the stop button as well. Set radio group ID. This is going to be group 1. Play button dot set toggle state. And then this will be true because this is going to be on when the other one is off and vice versa. Right? And then notification type. Don't send notification. Okay. And now we could do this. We could do a lambda function here, which allows us when we click the button, we want it to do something, right? So we say play button dot on click equals, and now we have this lambda, and we will say we'll leave this blank for the moment, and then we're going to go to our header file here, and now I'm going to create a function, and I'm just going to call it play. Let's just call it play, right? Void play. Now what I'm going to do is I'm just going to put this in here, play. Make sure you put a semicolon in there. So this is just a very kind of small function. So it's just saying when I click the button that I want the action to happen to this component, and that I want it to execute the play function. And what is the play function? Well, we haven't written it yet, but we're going to write it right now. So we got void main component play, and now here is where we go back to our play state, right? So we have these two play states, and one is playing and one is stopped, and I can just say we could just say play state. We need to go back actually. So what we need to do is we need to create an object of this class. Okay, so I could say play state. Okay, so that's just an object of this enum class here. Okay, and now I'm going to go down here, and I'm just going to say play state equals, and then capital play state playing. Okay, so I hope that I didn't do that too quickly there. So I'm just going to go through and explain this very quickly again. So I have two buttons called play and stop, and that obviously when I click one, I want it to execute a function called play. So we have this enum class that's called play state. So we're going to want to have certain things happen when the application is in a playing state, right? So the first thing that we want to happen is that if we hit the play button, that we change the play state to playing, okay? And that actually gives me a reminder. What I need to do is I need to give this play state a default value, okay, which we're going to say play state stopped. So we're starting the application in this state called stopped, right? And this is just kind of an abstract concept that I've just made up, right? So we're just saying, hey, we have certain things that we want to happen when things are playing, and certain things that are happening when things are stopped, and that this enum class just allows me to define what those things actually are and say, okay, when it's playing, I want these things to happen. I want the metronome to be going. I want the song to be playing. And when it's stopped, then I want everything to be stopped. I want things to reset, go back to some type of initial state, so on and so forth. And that's what play state stopped is about. Okay, so we're going to start this very simply, and we have a function called play, where we change the play state to playing, and now we're going to do a function called stop. Okay, and then here we're going to define what that means. We can say play state equals play state stopped. Okay. And now we can go back up here to our constructor, and we can just define this. We can just define these things. So we could set up our stop button on click equals, then once again, we want an action that executes to when we click on this, on the actual stop button, and we want it to stop, right? Make sure you put a semicolon there, because this is just like, it's like a little function right there. Okay, and we want to add and make it visible, and we got stop button, and there we are. Okay, so let me see what else. So we got to make these buttons visible now. So what I'm going to do is I'm going to go down here to resized. I'm going to set up a flex box. I'm going to call this flex box. Now I'm going to add the play and the stop button items to the flex box. Okay, so I have tutorials on this if you're not sure what I'm doing here. So we got flex box items, add, and then we got flex item, and then we could just say here we got, so our size, the size of our actual component is 200. So we could say that this is going to be 100, and then this will be our play button. Okay, so because that's our component there. And then we got flex box items, add flex item, and then we're going to set the bounds to 100. This is going to be stop button. So the main reason that I'm flying through all these without actually explaining them all is because I've done these in past tutorials, so I don't want to kind of go over old ground, so to speak. So if you're not sure what's happening with this Flexbox, be sure to check out the Flexbox tutorial. And then we could do flex. So we need to set a variable called bounds. So we could use that using a rectangle class of type int. This is called bounds. And then what we're doing is we're getting the actual area of the component that we're in, which is the main component, which is 200. So now I'm going to do flexbox perform layout, and we can see that the argument that we need there is a rectangle integer object. Okay, so then I can just say bounds here, and now I'm just going to execute this. And actually, before I do that, what I'm going to do is I'm going to go here to my audio block, and we'll do something here real quick just to show how this application now has a play state and a stop state. So what I can do is I could just say, now normally you aren't supposed to console anything out in the audio block, because if you had audio going, then it could block the audio audio callback, causing the audio to actually stop or stutter or do something that you don't want it to do. But since we don't actually have any audio actually happening at the moment, this is okay just for demonstration's sake. Okay, so I'm just going to put an if play state equals play state playing. And what I could do is I could use this dbg, which is like kind of like a C out, console out. And then what I'll do is I'll just put playing, print out playing to the console. And then else, and then I could put dbg and stopped. Okay, so now we're going to try this out. This shouldn't take too long to actually compile for us, hopefully. And so this is just going to demonstrate what happens, how we're going to switch between these two application states. Okay, here we are, we're linking, and here we go. So waiting for the application to pop up here. So here we are. So we have this little app here that has two buttons, has a play button and a stop button. We can see that it's canceling out stopped, and now I could hit play, and now we see that it says playing, and now I hit stopped and it stopped. Okay, so that's how that enum class kind of connects into the play and stop function and gives us this concept of something playing and something stopping. Okay, so that's good there. So that's fine. Great. So now what we're going to do is we're going to jump over to the metronome side. And so now once again, we're just going to take a moment and just really think about this concept of audio and what it means for something to be playing. So we have so when we have an audio callback, what's happening is that it's playing at a sample rate. So we should know by now about a sample rate and what it is, and it's how many samples that we're playing of audio a second. So normally that would either be 44,100 or 48,000 samples per second. So now when we think about it, what we could do is we could actually measure that, because what we could do is we could actually say, okay, well, if I look at the audio callback and I know that my buffer size is, let's say, 512, I know that when that 512 gets up to 44,100 values, that 1 second of audio is passed if I'm operating at a sample rate of 44,100, right? So that's pretty valuable, because what we could do is we could actually go into the audio callback and we could look at the buffer size, and we can use that to calculate how much time has actually elapsed. Okay, so that's what we're going to do. So the first thing that we're going to do is we're going to look at this concept of time. So the first thing that I'm going to do is I'm going to actually implement a timer, because what we're going to need to do is update. We're going to need to update how many more values we need until we're at our next measure or at our next beat. Okay. Actually, you know what? I'm not going to worry about that for now. I'm just going to do one simple function, and we can call this, let's say, void count samples. Okay, and this is just going to be something that counts how many samples we've had since since we started the song. Okay, so if we go back to our main component and we go into our audio callback, so we have this this object called audio source channel info, and this is where we could get our buffer information. So what we could do is I could say auto buffer equals buffer to fill dot num samples. Okay, so that gives us what our buffer size is, how many how many samples that we have in our buffer. So it would probably be something like 512 samples, something like that. Okay, so if I go in here, so if I click num samples and I go to jump to definition, I can see that this is of type int, the number of samples. Okay, so what I could do is I can now go back to my metronome, and here in count samples, I want to count how many samples have elapsed. So what I could say is int num samples, right? Or int, we'll just call it int buffer size. Okay, and now I'll do a function like this, and I'll go void metronome, because that's the class that we're in now, and it's count samples, and it's int buffer size. And now what we need is we need something that captures this number when it comes in. So what I could do is I could just create a private a private variable here. We could say int, let's just say samples elapsed, or actually let's call it total samples. And what I'm going to do is I'm just going to initialize that to 0. And then what I could say is now I'm going to do total samples plus equals buffer size. Okay, and what that's going to do is that's going to take and put add our buffer size as the buffer values are coming in. So each time the audio does a callback, it's going to add another 512 samples, or however many samples there are in our buffer size, to the total number of samples. Okay, so and then what we could do is we could console out total samples just to see what happens there. Okay, now what we could do is I can go back here and I can get rid of this stuff because we do not want any sort of consoling out happening in our audio callback. And I can say if play state equals playing, then what we need to do is we first need to create a metronome object. Okay, so we have this class called metronome. So now we need to get this into our main component. So what I could do is I could go up here to our main component header file. I could do include metronome.h. And now what I need to do is I need to create a metronome object. So I could say metronome with a lowercase m. And then what I could do is I could go back to the main component here, and I could say metronome dot count. Is it going to auto complete for me? I'll just complete it. So I'll just do count samples. And what do we need in here? We need our buffer in here. Okay, so I'm just going to walk you through that again. Okay, so we've created a public function called count samples. And then what I've done is I'm just adding the total sample, the buffer size to a variable, a private variable called total samples, and then I'm just consoling out how many samples there are. Okay, so let's go ahead and see if that works. Okay, so then I've implemented that here, this count samples function. And it's going to build, take a second to build. Here we go. So if this is working properly, when we hit the play button, we should see a number going up here in the console, and we can see that's happening, right? So now If I hit stop, we can see that it stops, right? And then I play, and then it starts again. But we can see that it doesn't reset when we stop. Okay, so but we can just fix that really quickly, right? So I hit play, and that makes sense, right? Because when we're playing, we want our song to be playing. We want to be filling it. We want to be filling the buffer with samples. We want to be processing audio, doing our thing. And when it's stopped, we don't want it to be doing anything, right? So that's what's happening there. So now we can just start adding some little helper functions here. So let's do like avoid reset. And then I will just implement this here. So we'll do this void metronome reset. And then what do we want to happen here? So at the moment, what's happening is that we have the samples, they're counting, and when we hit stop, it stops, but it doesn't reset to zero. So we want it to reset to zero, right? So what I could do is I could just say total samples equals zero. And that should do this. So if we do else if, actually, yeah, we need to do it. We just need to do an else, not an if. Sometimes I feel like if I do else if, it makes it more clear what's actually happening. But I was talking with some people that were a lot more experienced in C++ and just developing than me, and they were saying that to be kind of brief and as concise as possible, just make it else. And so we could say play state equals stopped, or play state stopped. And then what we could do is we could actually, so I'm just thinking here. Equality comparison unused. Oops, I just want this. So I'm just thinking whether to put the timer, the reset here, or whether to put it in the stopped. I think that I'm gonna just put it here in the stop, method here. So I will do metronome dot reset. Okay, and actually what I'm thinking as well is that I'm going to get rid of this here because I don't need that there. So the only thing that we need to happen is if it's in a playing state that we're counting the samples. And then when we hit stop, the metronome should reset. Okay, so we're just going to try that now. So here we are. And now we're going to hit play. Samples are playing. I hit stop. Now I hit play again, and we can see that it starts from 0. So we're at 49, 60 now. And now if I start again, it just starts from 0 again. So that's what we're going to do for now. We might want to have a separate reset button that just resets it back to 0. Maybe we want an application where we have a play button, a stop button, and a reset button that all have those different functions. Where if we hit stop and then we hit play again, it plays from wherever we were at. But if we hit stop and we hit reset, then it goes back to 0. But we don't have to worry about that now. So I think that's a good place to end this. That's a good place to end it now. What I'll do is I'll do one more function here. Let's do a prepare to play function. And what this will enable us to do is find out what sample rate that we're playing at, because we need to know whether we're at 44,100 values a second, or 48,000 values a second, or 96,000 values a second. And so what we need to do is we need to have some place where we're able to take that in for later processing, because we're going to need to do some calculations to find out our beats per minute. So I'm going to do another method here called void prepare to play. And here, so once again, we'll go back to our main component. I will look at what the sample rate expects. It expects a number of type double. So in here, I'm going to put type double. So double sample rate. And then I could go into the CPP here. I could do void metronome prepare to play. And then double sample rate. And then we're going to probably need to pass the sample rate around to different functions to do our calculations. So I can make a private variable called double M sample rate. So I'm going to do this, and then I'm going to change total samples to M, because that's just a member global variable, M total samples and an M sample rate. So I could do M total samples, M total samples, and then I could do M sample rate. So that's our global sample rate is equal to whatever number comes in there that we call sample rate. And then here I can put M total samples. Then I could go back into the main component, and I could go into prepare to play, and I could do metronome dot prepare to play. And we have a double sample rate, and I could just put my double sample rate here. Okay, so this is just kind of the first kind of getting everything set up, just getting kind of two application states, a playing state, a stopping state, and actually getting the actual values from the audio callback coming in. So there we are. So we have a play state, a stop state, and now we're counting samples. So that's where I'm going to end this tutorial. And then in the next tutorial, we're actually going to start calculating beats per minute and start looking at bars and beats and how to calculate those. So I hope you enjoyed this tutorial, and I will see you next time.